Hello everyone. So in the last video we have discussed about factors affecting compaction, and we have discussed about how the water content affected the compaction. And we have seen that the as we increase the water content, then at one point of time the dry density increases, that means more compaction, and then it decreases. And the point where the dry density is maximum, this point is called as optimum moisture content. In short form, it is called as OMC, optimum moisture content. Now, we all know that dry density is this formula, isn't it? And one second. And dry density is also equal to bulk density by 1 plus moisture content. So we will get back to this later. So now we will concentrate on this formula. Okay. So we have already got this formula previously also. We have done this discussion about how this formula of dry density. Now in place of the void ratio, we can also write omega into specific gravity in by degree of saturation, since ES is equal to GS into water content. Okay. Now when in normal situations, in normal situations, the degree of saturation, is like between what, 0 to 100%. Okay, when it is completely dry, it is 0%, and when it is completely saturated with water, it is 100%. Okay, and in normal cases, the value can range anywhere between 0 and 100%. And just for your revision, degree of saturation is what? If this is air, this is water, this is solids, so this is volume of water and this is volume of voids. So volume of water by volume of voids into 100, it was the degree of saturation. Okay, so in if fully saturated, then S is 100%, and if totally dry, S is 0%. And if it is 100%, then in the formula we write S equal to 1, isn't it? For 100%, in formula we will write 1. If it is 70%, in the formula we will write 0.7. Okay, now generally when 1 is the maximum value that can be obtained for S, so S is equal to 1 is the maximum value. Okay, that can happen. Okay, S cannot be 110%, isn't it? S can be maximum 100% saturation. Okay, so now let me go to a new screen. So S can be maximum 100% because or 1. Okay, because the volume of water, air, water, solids, this volume of water, this volume of voids. So volume of S is volume of water by volume of voids into 100. So what can be the maximum value of VW? The maximum value of VW can be what? VV. Okay, maximum value of VW can be VV when what happens? When the water completely fills the voids. So then it will become VW, and VW cannot become more than that because water can only occupy the voids. Okay, where else will it go? Okay, so maximum value of VW can be VV. Okay, and if VW is equal to VV in the maximum situation, then what will happen? VV by VV into 100 you will get in the maximum situation, and we get S equal to 100%. And this situation is what? When water is completely filling the voids, it is what? Fully saturated condition. Now, when S is 1, for this condition, for the fully saturated condition, when S is 1, what will happen? This will become the lowest. This whole term will become the lowest when S is maximum. When S we put 1, this becomes the lowest. This whole term becomes lowest. Okay, if we are putting highest value of S in the denominator, obviously the whole term will become lowest, and ultimately the whole denominator becomes the lowest, and ultimately Madi becomes the highest. Once more, if S is 1, maximum value of S is 1 for 100% situation, this term omega Gs by S becomes lowest. Okay, because denominator is maximum 1. So when this is lowest, omega Gs by S is lowest, then this 1 plus omega Gs by S also becomes lowest. The whole denominator becomes lowest, and ultimately when the denominator is lowest, the dry unit weight becomes highest. So we can say that dry unit weight is highest for S equal to 1. Okay, it means fully saturated condition. Saturated condition. Now, this S equal to 1, this thing about S equal to 1 is actually not practically possible. Okay, so we can only put it theoretically. Okay, can only be used theoretically. It means when we put the formula, S equal to 1, this can be done just theoretically. So this is actually what? Theoretical value. So this will be theoretical. it cannot be achieved in real. Okay, full s equal to 1 cannot be achieved in real. Okay, so why? Because the thing is that in fully saturated condition, when like there is soil and this whole is the volume of voids, isn't it? And the volume of water is also occupying the volume of voids. There is still somewhere some amount of air left. So S cannot be totally 100%. Okay, some air will remain. Okay, which ultimately leads to the fact that V this S cannot be equal to 100% in practical situations. Only theoretically we can use S equal to 1. Okay, in numericals, theoretically we can use S equal to 1. So you should understand the fact that fully saturated S equal to 1 becomes when water completely fills the voids, but this is not practically possible because some amount of air is still there. Some amount of air, no matter how much like perfectly you do the work, how much perfectly you do the work and completely fill the water in the voids. Okay, no matter how much water you fill in the voids, some amount of air will remain. You cannot expel it out. So ultimately water cannot fill it 100%. Okay, and ultimately S can be like 99.999%, but S practically in real cannot be 100%. Okay, in real, in real. Okay, so gamma d that we get by putting S equal to 1 is just a theoretical gamma d. Okay, so that is the thing that you need to understand. Okay, in general, whenever you use and this is the maximum Gammari you can get, maximum we can get, because S is maximum. Okay, and this is the theoretical, and we do not get it in real, we can only get it theoretically. Okay, so since we have discussed a curve like this, like this, okay, so here whatever gamma d we get, okay, whatever gamma d we get, okay, whatever gamma d we get, this is for uh, S values between 0 to 1. It can be 0.3 or it can be 0.4, 0.7, like that. Okay, that means 30%, 40%, 70%. Whatever we get in these situations, okay, these are for S values which are between 0 and 1. Okay, and if S is 1 theoretically, then gamma D will become high, like this. Somewhere we will get like this, gamma D will increase. Okay, for the same value of moisture content, the gamma D will be increasing. Okay, once more I am saying, for normal value of S, you will get something like this, which will be between 0 to 1, that means 0 to 100%, or 30%, 40%, 70% saturation. But in the same curve, if we keep all the other terms same, like Gs, specific gravity, then unit weight of water always same, then moisture content, then all these things we keep same, then what will happen is, if we put S equal to 1, then we'll get a curve at this location, because this gamma D value is higher than this, isn't it? This is for S equal to 1. Okay, and this will be for S from 0 to 1. Okay, so that you need to understand. Now let us go to a topic called as compactive effort. So now again we have to take the graph into consideration. So suppose this is the soil and you are giving some effort. Okay, we are giving some effort, mechanical effort. Okay, just some mechanical energy we are giving. Okay, and we are trying to compact the soil. Okay, now suppose at the initial stage your compaction effort is not so efficient. Okay, then suppose in the next stage, suppose this is the first stage where your compaction effort is good but you are not satisfied. Then in the second attempt, what you did is you gave some more force, more compactive effort. Okay, with a like a better machine, and with more power you are giving compaction. What will happen? The maximum dry unit weight, that means in this first case, suppose this one is the gamma D max, right? And this one is the optimum moisture content, where we get the highest dry density. This will shift, this gamma D max will be achieved at a lower value of moisture content. Okay, in the next step, in step 2, when you are giving a much higher compaction effort, then you get this gamma D max, that means maximum dry density, at a lower value of moisture content. Okay, so you will get a higher dry density and you will get it at a lower value of optimum moisture content. So the curve will ultimately, what will happen, the curve will shift to the top and to the right. So it will look like this, it will shift to the top and to the right like this. So it will be a new max. Okay, and you will achieve it at a lower. Suppose this one is the first one, this one is the second one. Okay, so first one you achieved the maximum dry density at omega 1 moisture content. When you are giving in the second time a higher compaction effort, then you will achieve a higher dry unit weight, and you will achieve it at a lower optimum moisture content, which is W2. So that is the concept you need to understand. Then if you keep on giving the compactive effort, like third time and fourth time you are giving much higher compactive effort, then what will happen? Suppose for the first time I am giving like this, this is the first one, then in the second time you will get it in this manner, in the third one you will get it in this manner, in the fourth one you will get it in this manner. Okay, so as you keep on increasing the compactive effort, the maximum dry unit weight will increase, and you will obtain it at a lower value of moisture content. Okay, so first one you are achieving it at omega 1. Okay, second one dry density you are achieving at omega 2, which is lower, and dry density is higher. Now third time you are applying more compactive effort, the dry density is again very high, and you will achieve it at a much lower moisture content. In number 4 again you will achieve with a higher compactive effort, you will achieve a much higher dry density, and you will achieve it at a lower moisture content. Okay, so now this is how the compactive effort affects the dry density. Okay, or we can say compaction. Now one thing you should know is when you are talking about the theoretical value, okay, that means these curves are for what? S between what? 0 less than S less than 1, isn't it? But same thing if we do for S equal to 1, maximum S value. Okay, then what will happen? The curve, the values we get higher, isn't it? We have seen that in the normal situation, this one, in if we use this for S less than 1, and if S equal to 1, we get it at a higher value. Okay, for S equal to 1. So now suppose for here, for first situation, for S equal to 1 we get it suppose here. For the second situation, for S equal to 1 we suppose get it here. For the third, suppose if we now put S equal to 1, we put this, we get this value here. And for the fourth, when we put S equal to 1, suppose the curve shifts here. Then if we join these points, then this is called as the line of optimum. Okay, or we can say zero air void line, because this line is made by considering what? S equal to 1, and if S equal to 1 means what? S we are considering 100% means no air remaining, which is what? Theoretically possible. Okay, and that's why this curve is theoretical. This curve is theoretical. So these points are nothing but these points. Okay, so once again, if you don't understand, if this is the first one, for 0 less than s less than 1, if we keep s equal to 1, keeping all the other terms equal, the curve shifts upwards because we get higher values. So these points are these. This is for curve 1, and this one is for curve 2, this one is for curve 3, and this one is for curve 4. Okay, and we join together and we get the line of optimum, and this is called as the zero air void line. So this lecture might be coming as too much for you all, maybe because you might be learning it for the first time. So please, I recommend you to go through it. Okay, and please, you also refer to the book uh, Gopal Ranjan and Rao, because this book is generally followed as a textbook rather than a reference book in various colleges. Okay, Soil Geotechnical Engineering book by Gopal Ranjan and Rao. It's a very famous book. Please go through it, and please try to understand these things. Okay, go through the video again and again until you understand. Okay, and I'm sure that you will understand it. I am very much confident. Thank you very much.